hopefully this makes sense. And now I want to describe another concept, very important concept for field of view in an image. Those who are using an image for your research should know the concept of field of view. It's very easy. So you have this object with this is called big field of view. This is small field of view. Okay. So field of view is an image referring to the extent of the image field that can be seen all at once. But in general, like if you have small field of view and then you expand for your presentation, let's say there's an original and you have chosen the small field of view, then this is how it looks like. So this is called digital zoom. And in fact, the information of pixel is there. So this is digital zoom, while if you really use an optics, so-called optical zoom, you still have fine information over here. Okay, so these two still have the same field of view, while the resolution will be different. So for example, zooming in a camera like this, and you actually compromises field of view for the resolution. And how do you determine field of view of an imaging system? Or more, let's say you are writing a paper, this is a figure. Any figure in your paper or report of an object of obscurity, you should put scale bar. This is very, very important. Because, for example, in this case, this object, this animal could be mouse or rat. But you know, rat is 10 times bigger, heavier than mice. How do we know from the image? No way. Without the scale bar, oh, this is 1 centimeter, so this must be a mouse. So scale bar is very, very important when you are presenting and interpreting any image, okay? And how do we know the field of view? Now you have a scale bar of 10 millimeter here. So overall here is about, let's say, 30, 40 millimeter. This is 40 millimeter. So that field of view is, let's say, 35 to 40 millimeter. What I mean by that millimeter is the ruler, the scale of the actual object space. That is field of view. So whenever you present your image to report, write paper, you must at least mention the field of view or put a scale bar so that readers automatically understand. All right, the next is about frame rate. We also care about dynamics of the sample if the sample is alive. So, or live or dynamic. So imaging speed. So we call it frame rate. It's very easy. How many frames per second? And remember those who loves watching YouTube movie or movies, our human eye cannot resolve transition of images that fast. But over certain higher frame rate, the animation appears smooth at how we can perceive and understand the movie. So that is about 30 frames per second. In the past, we also used 24 frames per second to make a movie. Even now, like even higher one, but about 30 frames per second or higher, we can actually see, we call it as a video rate because now we perceive it as smooth, as a natural animation. But the real question is, people ask about what's the right frame rate for real time? We call like sometimes paper title, or we've developed a microscope that can be fast enough for real time imaging. What do we mean by real time? In fact, real time just means it can be anything. So very important. Video rate is specifically over 30 or the same as 30 frames per second. So real time imaging do not have specific definition. Why? Let's say I'm just moving and you are watching my movement. So because this is a video rate, you are seeing me moving in real time. But if we are doing study under the microscope, the movement of cell receptors on top of the cell surface, they are so slow. So if I take image, 1 image per hour for over 2 days of tracing and chasing the receptor movement on a sticky surface, even it's 1 frame per hour, we can claim it real time because the objective is moving that slow. So it's a relative concept. I hope you understand